Hello everybody, I hope you're doing well. Welcome back to another video in the Probability and Statistics playlist. So I'm sure that some of you may have seen my past videos in this topic of probability and statistics and may have noticed that I haven't been posting in a while. I'm sorry for the inconvenience. A lot has been going on for all of us in the past few years. So with that being said, today we're going to be talking about estimators and in particular, this topic was something that confused me a lot when I was learning statistics, and I just felt that like some of the definitions and the theory kind of was a little vague. So I hope that this video can help to disambiguate that. So in particular, what are we going to be talking about today? So we're going to be talking about samples, and we're going to be talking about unbiased versus biased estimators. And the way I'm going to approach this topic is not through the general textbook theoretical sense, but rather through something you guys probably are familiar with. So hopefully this can help disambiguate the confusions you have and make sure you guys have a solid understanding on the topic. So how are we going to motivate this topic? Well, let's suppose we have a town, and this town is a typical suburban town with a considerable number of people, right? So let's say this box is the town, right? And the town has a bunch of people, right? Represented by these dots right here, right? And so on and so forth, right? And what is our goal, right? Our goal is going to be pretty straightforward. Estimate the average height of the resident. And okay, some people might be like, okay, well, I could just go into City Hall and maybe go ask the mayor for, the data on the residents and see if I can just comb through all the heights, put it in Google Sheets, take the average, and call it a day. Well, there's two problems, right? Number one, you can't just barge into the mayor's office and be like, give me the data on the citizens, right? That is an ethical, scenario you have to consider. And number two, even if we couldn't get, the data on all the residents from the mayor, right? We couldn't, you know, it might be impractical to, you know, go knock at every door and ask each person what is their height, right? That might invite a lot of weird looks from random people. They might be like, why are you asking me a question about height, right? So those two problems, right, prevent us from doing the straightforward approach, right? So what could we do instead? Well, if we have a lot of people, it's impractical to go and ask every single person, right? What is their height, right? But what we can do is take a subset of the people, ask them what their height is, and maybe use that to estimate the average height of the residents. And what is this idea? This idea is super powerful, and it's called taking a sample. So from the town, we can take a sample of people, right? So let's say this oval here is our sample, and the sample contains resident 1, resident 2, resident 3, all the way to resident n. And let's say the town had big N residents. So with our sample, right, or it would have m residents. Let's use a different letter. And this would be our sample, right? So our sample will be a subset of the town, right? It's just some of the people in the town, and we're going to ask these people x1, x2, x3, all the way to xn. I'm denoting for their height. And then from the sample, what do we get? Well, we can get what's called the sample mean. And the sample mean is no more than just, you know, 1 over n times the sum from I equals 1 to n of x sub I. This is just summing up the heights, right? Sum up heights, divide by n, right? So this should be pretty straightforward. We get the sample mean, right? And you might be like, okay, so Karthik, let's just collect, n people, right, from this town, right? Take the average and then call it a day. Well, there's a couple problems. Imagine, what if your sample, right, was just people living in your block, right? Couldn't that cause a bit of bias because you're taking people who are conveniently located to you and using that to generalize to the town, right? Remember what I said earlier, the town is kind of big, right? And, you know, taking a sample like that with people that you can conveniently reach might not necessarily give the best estimate, right? So what do you do? Well, we don't know how the sample was generated, right? But one estimate of the mean isn't necessarily perfect, right? We don't know, like, the givens about the sample, right? Or how it was generated. So what do? Well, what if we take a sample again, right? Because maybe the doubtful skeptic in this first sample might be like, I don't believe this mean. Give me another sample, like, so the skeptic goes out and collects their own sample, right? So this might be a different x1, x2, x3, all the way to xn, right? And they get their mean, right? And you can imagine that, like, we can repeat this process over and over and over and over, right? So when we repeat this process with all of these samples, what can we do? Well, we can simply, you know, plot the distribution of the sample means. And this might be familiar if you've watched some of my videos on sampling distribution of means and proportions, but we can construct a frequency graph, right? So we can have, the various means and how many samples do we get that have that mean, right? So you might get a distribution that looks something like this, right? And the more and more samples we have, right, we'll get a distribution, right? That's more like the bell curve looking thing, right? Because when we have more and more samples, right, then we're going to be more and more confident about our estimate of the population mean, right? And we're assuming in this case that the average height of the residents in this town is kind of unknown, and we're trying to figure that out. So if we take these samples and repeat this process over and over, right, we can get a decent estimate of, the population mean. And for a bit of notation, let's let mu denote the population mean and x bar to represent the sample mean. So what we're doing in this graph right here is we're simply taking a distribution of the sample mean. So you might be like, okay, Karthik, I remember this concept from your prior videos, but what does this have to do with estimators? Well, if we take this distribution of sample means, we can somehow get a sense of what is the expected value, or on average, what is this sample mean tending toward, right? What is it approaching, right? Well, in our previous videos, we've established that the expectation is this concept. It's this glorified version of average, right? So what we can do with this distribution right here, right, is figure out what is the expected value of the sample mean. And one thing that might be nice is if this expected value of the sample mean is equal to the population mean, this would be great. Why? Because then you can be sure that when you take these samples right here repeatedly and calculate the sample means, then you know that, like, the more samples you're taking, right, you are tending toward the population mean. And because the population mean height of the residence, right, is the true value, and x bar is what is the sample values you're getting, this is kind of what you know from taking your samples, then you're basically like getting an estimate that is tending toward the real value. And it's not off, right? So what is this called? This is called an unbiased estimator. So an unbiased estimator is no more than the fact that if I get an estimate, right, the estimate should be tending toward the parameter or the population value. So if we have that scenario, then we have what's called an unbiased estimator. Then the way of getting the mean through this formula right here is a reliable way to get a approximation for the population mean in this example, right? So this is what we mean by an unbiased estimator. If we had the scenario where somehow when we were calculating our mean, the estimate of x bar was not equal to mu, then we have what's called a bias estimator because you are off from the true value in your estimate. So in the later videos, we're going to be going through the estimator for the sample mean and the sample variance and proving if they're biased or unbiased estimators. So hopefully this video is a simple way to give you some intuition about the concept of an estimator. And if you have any feedback as to, my use of Autodesk Sketchbook and ways I can improve, please leave that in the comments. And yeah, hope to see you in the next video. Thank you very much and have a good rest of your day.